Somewhere in the North Sea right now, a pilot is sitting in a control room aboard an offshore vessel, flying a robot through the darkness of the ocean. He can't feel the current, he can't feel the cold, but through 6 cameras and a suite of sensors, he can see exactly what his machine sees, 300 meters below him. And with a pair of joysticks and a set of foot pedals, he's about to perform a task that would challenge the most skilled surgeon, guiding 2 hydraulic manipulator arms to make a precise mechanical connection on a subsea pipeline. This is ROV operations, and it is one of the most technically demanding, best compensated, and fastest growing careers in offshore energy. ROV stands for Remotely Operated Vehicle, an unmanned submersible connected to a surface vessel by an umbilical that carries power, communications, and data. ROVs were first developed for military use in the 1960s, but the offshore oil and gas industry adopted them quickly, recognizing that they could go deeper, stay longer, and work more safely than any diver. Today, ROVs are everywhere in offshore energy. They are on every drill ship monitoring the BOP and wellhead. They are on subsea construction vessels making pipeline tie-ins. They inspect wind turbine foundations, survey cable routes, perform emergency interventions on subsea equipment, and document the condition of infrastructure that no human eye would ever otherwise see. A modern work-class ROV is a formidable machine. It is typically a rectilinear steel frame about the size of a large car, fitted with a thruster package, usually 6 to 8 thrusters in various orientations, that allow it to move and hover in any direction. At the front, a bank of powerful LED lights illuminates the work area, and multiple cameras, forward-facing, downward-facing overview cameras, feed live video to the surface. The vehicle carries sensor packages including sonar, laser measurement systems, and acoustic positioning transponders. Most critically, work-class ROVs are equipped with manipulator arms, 1 or sometimes 2 robotic arms that can carry and operate tools, open and close valves, pick up objects, and make mechanical connections. These manipulators range from crude grab claws to highly sophisticated 7-function arms with wrists, elbows, and grip systems that can carry dedicated tooling packages for specific subsea tasks. The depth capability of work-class ROVs is extraordinary. Vehicles routinely operate at 2,000 to 3,000 meters of water depth. Some specialized systems are rated to 6,000 meters, deep enough to reach the vast majority of the ocean floor. Getting to the seabed involves a complex deployment system. The ROV is not simply lowered on its umbilical. The umbilical can't withstand that kind of tensile load over long distances. Instead, the ROV travels inside a large cage called a Launch and Recovery System, or LARS. The cage descends on a heavy work wire from a crane or A-frame on the vessel. Once the cage reaches a safe depth, perhaps 50 meters, the ROV releases from the cage and flies to the worksite under its own power, while remaining connected to the surface via the umbilical, which is fed out continuously from a reel on deck. The people who fly these machines, ROV pilots, are a mix of former divers, electronics engineers, marine technicians, and people who came from completely different backgrounds and found their way into the profession through technical training schools and cadetship programs. Senior ROV supervisors and pilots can earn between $100,000 and $200,000 US per year, depending on experience, client, and the complexity of the work. Some highly specialized pilots working on intervention and drilling support ROV systems earn significantly more. The work is offshore, the same rotation system as other offshore jobs, typically 28 days on and 28 days off, meaning that in a year, a senior ROV pilot may work only half the calendar days and earn those figures. The path into the profession is more accessible than many offshore roles. ROV pilot technician courses exist worldwide, training candidates in vehicle systems, electronics, hydraulics, underwater navigation, and tooling operation. Entry-level ROV positions, pilot technicians gain experience aboard vessel across a range of clients and project types, working their way up through pilot to supervisor and beyond. The craft element of ROV piloting is real and significant. Flying an ROV in strong currents, limited visibility, and close proximity to delicate subsea structures requires an instinctive three-dimensional spatial awareness. Operating manipulators to perform precision tasks while watching through cameras at angles that don't correspond directly to physical sensation is a skill that takes years to develop. The best ROV pilots are fluent in their machines in the same way a skilled surgeon is fluent in a procedure. Quick, confident, economical in their movements, always anticipating